All right. All right, we're connected. Awesome. All right, welcome to Off Topic number 1. This is just going to be a quick video. I guess the first in this series of things that just are not related to audio amplifier repairs. Today's topic is going to be 3D printing. I'm rebuilding an old original Prusa, kind of upgrading it and making it into a high reliability, high accuracy printer. I got the parts for it very cheaply, and I wanted to put it back together and make it work. So this is part of that adventure. If there is some interest, I will cover some of my modifications and post some links on Thingiverse to the updated design for this printer. But let's get on to the topic for today, and that is 24 volt conversion. So I have two different versions of MEGA2560, and I'll zoom in a little bit here. So this is just your off-the-shelf, I believe it's official Arduino version, and then this is a clone, and this is a Torino, I believe. Yeah, this is a Torino. This is the one that actually came with it, and this is one that I had laying around. But what we're going to do is we're going to make it run on 24 volts, and I call this the easy way because it doesn't involve modifying anything on the ramps board, cutting off diodes or anything like that. It's just pretty straightforward. We're going to take the regulator off, and this regulator is, at least on the official board, it's an OnSemi 117-5, which is a linear voltage regulator. I pulled the data sheet up. I don't have that data sheet to share with you, but I can look at it. And for a 5 volt, it can take 20 volts input maximum. And if we want to run at 24 volts, that just is not going to happen. The device is going to get too hot, and we're just going to burn that up. So one of the ways to get around that is to go to a little switching regulator. And these things have come down a lot in price. They're pretty easy to get and find. This one is a Recom, and it's the 78E series, and it's 1 amp. The original regulator is rated for 1 amp, so we want to make sure we use a 1 amp. This is an open frame version. Let me zoom in a little bit here. So they follow the leg pattern of a T0220 package, or standard. I believe it's 0.1 pitch spacing. But this is an open frame, so you can either get them open framed, and this is only a half amp one. This is tiny, but they have everything needed to be a fully functional little buck switching regulator, all on a tiny little board. This one is just potted and enclosed, but same thing. So what we're gonna do is we're gonna take off the switching, or I'm sorry, the linear regulator, and we're just gonna replace it with the switching regulator. And it's pretty easy to do. I already removed the parts off of this board. I also removed the DC input jack. You don't really have to do that, but for what I'm going to do, this makes it a little easier. So I want to attach this to the original pads. And I have the pinout of the original device over here. So the pinout goes as follows, and this is looking top down at this device. You start off with a ground, then you have your output, and then you have your input. And if we look at the new device, if we're looking at the bottom of it, we have the input, the ground, and the output. So it's not pin for pin compatible, or pin for pin compatible as a replacement. So we have to do a little bit of fancy work to get this to fit. Now you might be able to find one that has the pin out that matches. This is just the one that I have, so I'm going to use this and show you how to make it work. So what I'm going to do is I'm going to find out which two of these pins match. And on this one, so I have ground and VN are next to one another. And on this one, ground and VN are spaced by a pin, so that combination won't work. So I have ground and V out that are also next to one another. And on here, I have ground and out. So ground and out is pins 2 and 3. and ground and out on here is pins 1 and 2. So I can take my ground, which is pin 2, and my out, which is pin 3, and I can just offset them by 1 pin. So my ground is pin 2, pin 2 is my ground, and that'll go to the ground. My out is pin 3, my out will go to my out. So we're just going to offset this device by 1 pin and put it on the original pads. So to do that, I'm just going to bend these legs over. Bend them over as nice as you can. And we're going to put it right on top of the original package where it went. And you'll see why I removed the DC jack, because it overhangs a little bit where the DC jack would go. And we don't have to worry about heights or anything. The height of this device is about the same as the DC jack. And I'm pretty sure the ramp sport doesn't go over in that area anyway, so even if it did, it wouldn't interfere. But it really becomes as simple as soldering it on. Now, underneath the input pin, we have some solder mask there, so we should be okay. If you want to, you can take a piece of Captain tape or something else and use that to insulate that pin. As long as the solder mask is intact, it's really not necessary, but it doesn't hurt to add that as an extra step. So I'm going to fire up my soldering iron. Give it a second to heat up. And to get this DC jack off, I used a solder sucker. If you don't have one of those, you can easily just snip the pins off. Just be careful. You can even, just take a razor blade and just kind of work them until you just cut the legs off. I always recommend cutting to remove packages. Desoldering just usually doesn't work. So when you want to get this voltage regulator off, take a flat blade X-Acto knife and just get down in there and just work and just cut the pins and then cut this top one off. And then after you have the device removed, you just go in there with your soldering iron and you can just take the leftover pins off. It's really easy and it doesn't do any damage to the board. If you're going to remove the device, you don't need to save the device, but you do want to save your board. That is important. So, I apologize, my desk is a mess. Got a million things going on. I am going to put some solder on the center pad, and this center pad is my output, and my output is pin 3. So I'm going to make sure I got pin 3, and I'm going to solder it right to that surface mount pad. And we'll make sure we get it centered as best we can. That's it. Now I'm going to go and do pin 2. Solder it on there. Make sure we got a good joint. So now we have 2 of the legs soldered down. Now we have the one remaining that's left, and that is our input. So we have to go from pin 1 to originally where pin 3 was. And the easiest way to do that is just going to be to take a little jumper and just go between the pins. I like to use solid wire. You can really use anything you want. You just have to make sure that it is away from the other 2 legs so it won't short out. But other than that, there's really no other requirements. So I'm going to find a piece of wire. I like to use resistor legs. They form fairly easily, and they're usually a little bit thicker in size, so you can get a decent amount of current carrying capacity through them. So I will grab a resistor, preferably one that I'm not going to use. There we go, one of these guys. And I'm just going to snip the leg off of it. And you could use copper wire, or, you could really use anything you want. This is just the way I like to do it. So I'm going to snip this guy off. Then I'm going to take a pair of pliers, and I'm going to form a little bridge. I want to add a leg. And let's zoom in so you can see this a little better. And this is really overkill, but that's how I like to do it. So we're going to put a little leg on there, and that leg is what's going to go on this pad down here. And I'm going to trim it, make sure it's not overhanging too much. And I'm going to mount this so that it sits as flush with the device as possible. So we have our leg. Now I'm going to make the section that goes across. And try and get your bends and angles correct. And again, this is a little bit overkill, but it wouldn't be a very interesting video if we didn't make it overkill. Let's see there. So you can see there's part of the bridge. Now we got to get the length right. So I'm just going to kind of eyeball it. See if I can grab it with my tweezers to mark the spot. And it doesn't have to be perfect, just kind of close. So I'm just kind of marking it with my finger right there. Bend it down. And then we'll match it to the other side as best we can. Helps if you can see what I'm doing. And then we'll trim the pins. And we can, you can make fine adjustments as needed after you get it all together. So here's what we have. We have a little bridge that we made that has two legs sticking out. If we can get her to focus. There we go. There it is. Just this little guy here. Quick and simple, just out of an old resistor. Actually, that's a new resistor, but it's not being used for anything. And we'll do a test fit. And you can put it with the legs up against the device. You can put it with the legs away from the device. However you think it would fit better in there and is easier to install. I'll install it with the legs away from the device. That way I'll have a little bit better control when I'm soldering. So we make sure it fits, check the fitment. I'm happy with that. Throw a little solder on the pad. Grab my tweezers. These are the worst tweezers for holding something when you're soldering because they have a fine point on them. I need to get a set of flat blade ones, but in a pinch for right now they'll work. So we're going to line this up. Going to heat that pad up and just drop it down on there. Now for our other pad, I want to make sure that we're going to have good contact on there so we can carefully, don't go in here crazy and risk tearing a pad off, but get in there with your tweezers and just kind of form that leg down. And make sure we're right on top of that other leg of the regulator. Take your time, it's not a race, not a hurry. But you want it to look good, So now we will solder it to that leg. And if you really wanted to, you could have bent that leg up so it's on the front of the device, but it's harder to solder that way and you're going to melt into the device. So we will solder it. I'm actually getting more solder on the pad for the, there we go, DC jack than I was for this. But so we got a good solder joint on there and our little bridge is completed. And you'll see it just goes from pin 1 over here to pin 3 over there. And that is all that is required to do a 24 volt upgrade on our ramps and our MEGA2560 board. Now, one thing you want to check, make sure your capacitor values are able to handle the higher voltage. These are rated for 25 volts, which is kind of on the edge, but as long as you don't turn the voltage up on your power supply over 25, they should be okay. If you really wanted to, you can pop these off and replace them with 50 volt versions. Again, it might be worth it, it might not. I'm just going to run them as they are. If they fail, I'll replace them after they fail. I'm going to run it right at 24 volts. I'll check it with a multimeter, so I'm fairly certain that I should be okay. But Here's our original. And I believe that these are recommended you run off of 12 volts max, because this guy starts getting hot. This is our converted version, and the input voltage on this, I think, is like 36. I'd have to look at the data sheet, but it's well over 24 volts. Just for the heck of it, I'll pull it up just so we know what that is, because if you wanted to, you could change out your capacitors and run it at a higher voltage. So let's look that up really quick, just so I can give the correct info to anybody that is curious in doing this. So I'm looking up the data sheet on DigiKey, which is where I order most of my parts from. And okay, so this is a 78E 5.0 -1. So this will do anywhere from 8 to 28 volts, and it outputs 5 volts at 1 amp. So we should be good to go. It's saying that this is an 85% efficient switching power supply, which is pretty cool. Again, it's a drop-in replacement for what we got. So I know this wasn't a super in-depth and complicated video, but this is meant to just be, like a quick tips and trick, demonstration of how you can just take something that, normally isn't what everybody else has been doing, and you can apply like a different method and hopefully end up with some better results. So I hope that some of you will find this information useful. I know that a lot of people want to run higher voltages on their 3D printers, and hopefully this will help you. So let me know in the comment section what power supplies you use. If you want to, make a video and show how you soldered on your switching power supply, and if you want, share how it helped you out with your 3D printer. Appreciate the time that anybody takes to watch this, and I hope that I helped you out. I figured it's no fun doing this if I can't show that it actually works. So let's just take a minute, power it on. And that will be more fun for everyone. So I have a bench supply. We got it at 24 volts. It's current limited to right now 5 amps. We don't need 5 amps. We can turn that down. It really doesn't matter, but alright, what was our original pinout on this? That's going to be fun to figure out. I guess it doesn't matter because we know that VN is our bar going across and ground is... Let me find a ground plane to hook up to. We might be able to do it right to the case of our device here. So ground on our new guy is pin 2. So pin 2 is common with the shell on the USB connector. So what I'm going to do is I will take my ground to the shell of the USB connector, and I will take my VN to my VN. And there we go. We are powered on. And I don't have an easy way to show you the power supply, but we are at 23.3 volts and it's drawing 0.2 amps. And it is happy as can be. So 24 volt conversion, proof of concept. Let me see. Yeah, I don't know if the camera will get this. Let's try. Let's try just for the heck of it, just because I'm bored and I have the time to do so. Give everybody a sneak peek of my totally destroyed desk. Nope, camera's not going to catch the power supply. Maybe I can cheat and bring it out a little bit. Yeah, there we go. 23.3 volts. The proof is in the pudding. There it is. So there we go. I hope that helps you guys out. Like I said, you know, a lot of people are doing 24 volt conversion. A lot of people really aren't using MEGA2560 boards anymore. Everybody's going to like the MKS and you know that stuff. So I don't know. There's kind of a fun aspect in taking legacy hardware and upgrading it and making it work as well as some of the new printers do. I mean, you don't really need a huge amount of processing power for some of these. And it's just a fun project. So you can take a piece of old hardware and give it new life just by doing a simple modification. You know, putting a couple dollars into a part upgrade on there, and you have the best of both worlds. You don't have to modify your ramps board now and cut diodes off of it. You can just hook your power supply up directly, and you're good to go. One thing to keep in mind though is, of course, I have to fix my camera here. Your fuses that are on your ramps board, your fuses might not be rated for 24 volts. I know that these are like resettable ones, and some of them are only rated for like 16 volts. Like on my board, they're both rated for 30. But if you have a board that doesn't have these resettable fuses that can handle the higher voltage, cut them off. Bridge these fuses with wires, and then just put inline fuses to your power supply coming in. That's another really easy way to get past the limitations of a older ramps board. So, you know, that's another little tip. Like this board can handle 30 volts, so I'm just going to leave it as is. But and even if you want to run higher currents too, I don't know what these are rated for. I think this is 9 amps and 9 and 5 amps. So that might not be enough on these, so I might end up cutting these off anyways. But it's perfectly safe and acceptable to cut off these, bridge them with a piece of wire, and then move your fuses to your input side over here. Don't run without fuses. You need fuses. Fuses prevent fires. So make sure you do that. But another little tip. I won't do a video of that. That seems pretty straightforward. But again, I appreciate you guys tuning in. I hope I could help some of you out, and share with me how I've helped you by showing you how to do this mod.